We all know light speed is constant in any circumstance. According to current theory, if a boy Alex stood at the center of the train, he then emitted two lights into opposite directions. No matter if the train is moving or not, he will observe the lights will reach both walls at the same time. Meanwhile, there's another boy, Bob, standing outside the train watching Alex's experiment. Since Alex's train is moving towards right, Bob will see the light heading to left hit the wall first. It's because the left wall was moving to the light whereas the right wall was escaping from the light. When light speed keeps constant, it will be the result. This observation difference between Alex and Bob is a classic example to introduce theory of relativity. Now Alex has decided to change his experiment setup to a laser ring. Let's see what will happen with wave perspective. In Alex's observation, the lights start from the center of the train, hit both walls at the same time, travel back to the center, and meet again simultaneously. Since light speed is constant, everything is nice and in harmony. Now it's Bob's turn. He will see the light heading left hit the wall first as the wall is moving to right. When the lights reflect, the situation will reverse. The left light will need more time to reach the center since the train is moving right escaping from the light. But since both lights travel the same distance, they will finally meet again at the center simultaneously. As you might already realize, from Bob's perspective, since he sees the light sources moving, he will observe redshift and blueshift effects. Is it another trick due to relativity, or is it a real contradiction? To figure it out, Alex makes a small modification to his setup. Alex adds an interferometer to the setup that can slide horizontally within a finite length d. Alex would like to count the fringe to verify if there's any shifting. If redshift or blueshift exists, the number of fringes being counted when sliding the interferometer should be more than no shifting exists. According to current theory, from Alex's perspective, Alex should not be able to observe any speed differences for both lights. Let us assume the number of fringes Alex counted is x. But from Bob's perspective, since the train is moving, one wall is approaching the light source while another wall is escaping from the light source. There should be redshift and blueshift effects. Therefore, when Alex slides the interferometer, the number of fringes counted at Bob's side should be more than x. Here comes the question, whose number should be correct? My answer is, according to Haffel-Keating experiment results, in this case neither Alex nor Bob is the correct static reference frame. We should use the center of Earth as the static reference frame instead. In Haffel-Keating experiment, we found that the clock on the plane flying to the east runs slower than the clock on Earth's surface, and both clocks run slower than the clock on the plane flying to the west. Because when you use center of Earth as the static reference frame, all three parties are in motion, whereas the plane flying to west moves the slowest, thus having the smallest time dilation and the fastest clock. This means we cannot simply take any point as static reference frame. The nature knows where the static reference frame is and knows how fast each object is moving. In Alex and Bob's case, we at least need to take Earth's center as a static reference frame to get the correct results. If the train is moving from west to east, Alex should be moving faster than Bob. Thus, the number of fringes observed by Alex should be more than those observed by Bob. If the train is moving from east to west, due to Earth's rotation, Bob should be moving faster than Alex. In this case, the number of fringes observed by Alex should be less than those observed by Bob. Since both Alex and Bob are moving, redshift and blueshift effects should be able to be observed from both perspectives. As long as the train is moving, Bob's fringe count cannot be equal to x. And by this experiment setup, Alex should be able to measure the train's speed without reference to external parties. He can just calculate his current speed from the difference between observed fringe count and static fringe count. It's how you can make a speedometer for the spaceship. Indeed, with this setup, you will find even the center of Earth is not the static reference frame. Since the Earth is circulating around the Sun, and the Sun is circulating in our galaxy, and our galaxy itself is also in some sort of motion. Through this experiment, you will identify the real unique static reference frame, a zero-velocity reference. In other words, I am saying speed is not relative, since it violates Halfel-Keating experiment observations. And in fact, I can explain other phenomena such as the negative results of Michelson-Morley experiment, Lorentz contraction, and time dilation if speed is absolute but not relative. As a short conclusion, by using the below setup, you can measure your current speed by counting the fringes and comparing the results with no redshift occurrences. But to determine the moving direction, you will need to measure the difference between before and after the acceleration. And with measurements in all XYZ axis, you will get the accurate velocity in the 3D space. Being able to measure the velocity has many practical usages. For example, after knowing the Earth's velocity in space, you can subtract it by your own velocity to get your geolocation without the GPS satellites. Since the Earth is rotating, every point on the Earth should have a different velocity. You can also get a more accurate age of different galaxies in space. The one we observed with the largest redshift might not be the oldest galaxy. It might be just because it's moving in opposite direction to our Earth. To make this video short, I will stop here. If you find this video makes sense and want to know more about how my hypothesis explains Lorentz contraction and time dilation, there is a longer full version on my YouTube channel. Please feel free to take a look. Thanks for watching.